Hi, my favorite people. Welcome to our first official Screencastify video. I'll be making these every week for us so that you can start learning the new topics for the fourth quarter. And then if you have any questions, feel free to join me on the 2 Zoom times that you can find in Schoology. And you can come and ask me any questions if this doesn't make sense to you. But this week we're talking about my favorite topic, which is probability. So probability is the likelihood that something will happen, right? So we use probability in our everyday life without even really knowing that we're doing it. Probability can be expressed as percents, decimals, or fractions. But normally we talk about probability in terms of percentages, right? So right now, if you were to go to your mom and say hey, Mom, I want to go to the store. Your mom would be like, there's a 0% chance we're going to the store, right? We're in the middle of a pandemic. We're not going to the store. So 0% means it's not going to happen. The likelihood that it happens is none. You are not doing it. But probability can range all the way to 100%, right? So everything gets better. Your mom wants to go to the store. She's like, 100% chance we're going to the store today, which means you are definitely going to the store. And then obviously there's percentages that range everywhere in between those 0 and 100%. This week specifically, we're going to focus on experimental probability versus theoretical probability and how those two things are different. So experimental probability is what actually happens if you do an experiment. Actually happens, right? Here we go, I'm writing. So what actually happens? So say I have a coin and I flip the coin 10 times and it lands on heads 6 out of the 10 times. So the experimental probability, or the probability of heads, right, would be 6 out of 10 because I actually flipped the coin 10 times and I saw that I landed on heads 6 out of those 10 times. That's the experiment that I did. That's what actually happened. Theoretical probability is what should happen, right? So that's in a perfect situation, what should happen. And what should happen if you have a coin and you want to know the probability of heads is that you will land on heads 1 out of every 2 times. Because if you think of a coin, it has 2 sides. One of them is heads. So in theory, right, kind of that main word, in theory, we should land on heads 1 out of every 2 times. When it comes to questions with theoretical and experimental probability, a lot of times it's about what's the difference between the two. So if we think about our coin experiment, right? Let's say earlier today, I actually flipped a coin 10 times. And with that experiment, I landed on heads 6 out of that 10 times, right? But in theory, I know the probability of landing on heads should really be 1 out of every 2 times. So a question would be what's the difference between the experimental probability of what I did with the theoretical probability of flipping a coin? So literally they mean the difference, right? Subtraction. So if I take the probability of flipping heads with my experiment, which was 6/10, and I subtract the theoretical probability of landing on heads, which is 1 out of every 2 times. Now remember, when we subtract fractions, we need common denominators, right? That's a 5th grade review. So now I have 6/10 minus 5/10, which is half. 6 minus 5 is 1. My denominator stays the same. So the difference between the experimental and the theoretical probability is 1/10, right? That's the answer. It's just that simple. When you're talking about theoretical and experimental probability, you're talking about what we call simple probability, which means only one thing is happening, right? We're not doing compound probability quite yet, not until next week.